in this question, we have to write down this quadratic expression x square minus 7x plus 5 in the form x minus a the whole thing square minus b, which if you remember is called the completed square form. So the way to do this is very simple, is that we take the quadratic expression, we take the first two terms, and then we leave a bit of space and then write the constant, which is plus 5. Now, in order to bring this in completed square form, there is a certain value that needs to be added and the same value needs to be subtracted as well. Now, what is that value? That depends on the coefficient of x, which happens to be 7. If we ignore the minus sign, otherwise it's minus 7. So the value that we're going to add is always half the coefficient of x, and the coefficient of x is 7, so half of 7 would simply be 7 upon 2. Now if you've added a certain value, we need to cancel the effect, and we can do that by simply subtracting the same value. So the first three terms are going to get compressed and be written as, they're going to be written as x minus 7 upon 2, the whole thing squared. And the reason that is that if you were to expand x minus 7 upon 2 the whole thing square, you'll notice that you get x square minus 7x plus 7 upon 2 the whole thing squared using the identity a minus b the whole thing square. Now we further need to evaluate what 5 minus 49 upon 4 is equal to. 49 upon 4 is 12.5, so I just need to figure out what 5 minus 12.5 is going to be. So x minus 7 upon 2 the whole thing squared as it is, plus 5 minus 12.25. So 12.25 minus 5 is going to be 7.25, and then we're going to have a minus sign because of sign of the greater value is negative. So this is going to be minus 7.25. Okay, so with this sorted out, we have successfully done part A. So I'll just write the answer in the space that's provided. Now we do part B, in which we have to write down the minimum value. Now notice there is a keyword in the question, which is the word hence. Now this means that I have to use the answer in part A. So the expression that we got to in part A was x minus 7 upon 2 the whole thing square minus 7.25. Now how are we going to solve this? Well, if you notice, there is a fixed value, and that fixed value is minus 7.25. Why? Because this value is not dependent on the value of x. This will always be there. Now however, if you look at the bracket, you can see that just this part, x minus 7 upon 2, is dependent on the value of x. So the least a square value can be is 0. Why? Because if the entire bracket is to become negative, squaring it will make it positive, and if it's already positive, squaring it will make it squaring it will remain positive as well. So what I'm going to do is I'm going to assume that x is equals to 7 upon 2. What will happen that way is that 7 upon 2 minus 7 upon 2 will be 0, and then the whole bracket will become 0. 0 minus 7.25 is simply going to be minus 7.25. Now we do question number 15, in which we have 168 and we have to express it as a product of its prime factors. So this is a very fairly simple question. We're going to write 168 here. We're going to start dividing it by 2. So 2 8s are 16, 2 4s are 8. Then we're going to divide it by 2 again, so we're going to have 42. And then by 2 again, so that's 21. Now we can divide it by 3, so 3 times 7, and then finally by 7. 7 ones are 7. So 168 is basically equal to 2 cubed multiplied by 3 multiplied by 7. So I'll just write it here, 2 cubed times 3 times 7. Now we do part B, which says the highest common factor of 168 and n is 42. So this means that 168 and n both are multiples of 42. So both of them happen to be multiples of 42. So what I'm going to do is I'm going to quickly write down a couple of multiples of 42. So 42 times 1 is going to be 42. 42 times 2 is going to be 84. 42 times 3 is going to be 84 plus 42. Let's figure it out. 42 times 3, that's 6. 4 3s are 12. So that's 126. So basically what I'm looking for is I'm looking for a multiple of 42 that falls in this range, which is 200 and 300. So let's find out what 42 times 4 is. that is going to be equal to 168. So again, we're not there yet. Now let's find out what 42 times 5 is. So that is going to be equal to 210. So we have one value. And let's find out what 42 times 6 is going to be equal to. So adding 42 in 210 is going to give me 252. So these are my two final answers, 210 and 252. Now let's move on to the next question, which is question number 16. In question number 16, we have two triangles A and B, and we have to fully describe the transformation that maps A onto triangle B. So since everything has remained the same, the orientation and the size, so this has to be translation. Now once we've stated that this is translation, with this you have to write down what the translation vector is, and in order to find out, what we have to do is we have to take one point of A, which is the object, and the same point on B, which is the image, and find out what we have to do in order to get from A to B. So we have to move 1, 2, 3 units to the left. So to the left means -3, and then we have to move 1, 2, 3, 4. 4 units up, so that means +4. So there you go, -3 and 4 is the translation matrix. Now we have triangle A is mapped onto triangle C by an enlargement with center 0, 3 and scale factor -2. So 0, 3 means that we're talking about x0, y3. So here's the center of enlargement, and the scale factor is -2. So scale factor -2 means that our image will be greater than the object, and it will be on the opposite side of the center. So the way to do this is like this, so here we have 1 unit, alright, you can say it's one diagonal. So what I'm going to do is I'm going to extend this in the opposite direction, and I'll double the length of the diagonal. So now it is going to be 2 diagonals, but on the opposite side. So here's one point, and then let's do the same with the other point. So now we have, let's take this point. Now this line is of 3 units. Doubling this means it is going to be of 6 units, but on the opposite side. So here we have it. Now let's do it for the third and the final point. Now once you've done this for 2 lengths, you can figure out where the third length is going to lie, and you can do that by looking at this point and the point that we are left with. You can see that the object is 2 units towards the left. So that means now this length is going to be of 4 units, but it is going to be on the right side. So that means the image of this point is here. Now the image of this point is going to be 4 units towards the right. So 1, 2, 3 and 4. Now why has the direction changed? The direction has changed because our scale factor was negative. So this triangle is triangle C. So I'm going to call it triangle C. Now let's move on to the next question, which is of probability. Now here we have to complete the tree diagram. We're already given the probability. Let's read the question first. In fact, Nima has these 6 cards. Each card has a shape on it. She takes 2 cards at random without replacement. Okay, so the key word is without replacement. Complete the tree diagram. So the probability of drawing a circle we can see is 4/6, and the reason is very simple, because we have 4 circles and 2 triangles. That means the probability of drawing a triangle will be 2/6. Now once you've taken out a circle, that means I'm going to cross this out. So now we can see that we have 3 circles out of the 5. So how many triangles do we have? We have 2 triangles, but the total number of cards are now 5. But what will happen if the first card taken out turned out to be a triangle? So let's cross out a triangle now, and this way we still have 4 circles, but the total number of cards are 5, and we only have 1 triangle left, and again the total are 5. So that's a tree diagram completed. Now let's see what the question says now. Find the probability that the shapes on Nima's 2 cards are the same. So this can happen 2 ways. Either she gets both of them as circles, or both of them can be triangles. So what's the probability of drawing a circle in the first attempt? It's 4/6, and in the second attempt is 3/5. Or she can get both triangles, so that can happen by 2/6 is the probability of drawing a triangle in the first attempt, and then 1/5 the probability of drawing a triangle in the second attempt. So let's simplify this. So that's 12/30 plus 2/30. 12 plus 2 is 14. 14 upon 30. If I simplify this, this is going to be equal to 7 upon 15. So there you go. This is my final answer. Now let's move to question number 18. Again, a fairly simple question. We just have to plug in the value of p. So let's just do that right away. 4 times minus 2 plus 2, and then 3 minus minus 2. Got to take care of the signs here. So 4 times minus 2 is minus 8 plus 2, and then 3 minus minus is going to turn it into plus 5. So minus 8 plus 2 is minus 6, 3 plus 2 is 5, so we have minus 6 upon 5. Rearrange the formula to make p the subject, so we start by cross multiplying. So 3 minus p is going to get multiplied by r. This is what I'm doing, I'm cross multiplying, is equal to 4p plus 2. So 3r minus rp is equals to 4p plus 2. Let's bring all the p's on one side and everything else on the other. So 3r is going to remain here. I'm going to take 2 on the left hand side, so minus 2 is equals to 4p is going to stay here, and then I'm going to bring rp on the other side. So 3r minus 2 as it is, and the objective of doing this was so that I could factor out p. 4 plus r is what I'm left with. Now 3r minus 2, and then 4 plus r, when it will come on this side, it will get divided, is equal to p. So p is equals to 3r minus 2 upon 4 plus r. Now we have question number 19, which says y is inversely proportional to the square of x. So let's write this down. We have y, and then we have x square, and let's write that they are inversely proportional so that I know I don't have to cross multiply, I have to multiply head to head. So when x is 4, so 4 squared, y is equals to 10. Find the value of y when x is 10, so that means 10 squared. Now since they are inversely proportional, that means I'm going to multiply this head to head. So 10 times 4 square is going to be 16 is equals to y times 10 square, which is going to be 100. So this is going to give me 160 is equals to 100y. Y is simply equal to 160 upon 100. The two zeros get cancelled out, so y is equals to 1.6. We can see that when x has increased, y has decreased, and that shows that they are in fact inversely proportional. Now let's do part B, which says describe the effect on y when x is halved. So what we can do here is we can go back to the original relationship which says y is inversely proportional to the square of x. We can take the original values 10 and 4 square. These set of values were given to us in the question, that x was 4 when y is equals to 10. Now taking the half of x means x is now going to be equal to 2, and then we're going to find out what's going to happen to y. So let's see, 10 times 4 square, remember we are multiplying head to head since they are inversely proportional, is equals to y times 2 squared. So 10 times 4 square means 10 times 16 is equals to y times 4. So let's evaluate this and see what do we get. We get 10 times 16 upon 4. So 4 ones are 4, 4 fours are 16, so y is equals to 40. So you can see that y was 10 and now it is equal to 40. So what has happened to the value of y? What is how can we describe this effect? We can say that it gets multiplied by 4, or you can say it becomes 4 times of the original value. Now let's do question number 20. Simplify. So we start by looking at what the power here is. The power is negative, and the way to turn this into positive would be to take the reciprocal of the entire fraction. So x power 5 y power 9 is now going to be in the numerator, and then 9x power 7 y is going to be in the denominator, and doing this will make the power positive. So now what we're going to do is we're going to simplify whatever is inside the bracket. So if we look at x, we have x power 5 in the numerator and x power 7 in the denominator. So when two same bases are divided, the powers get subtracted. And then let's look at y. We have power 9 in the numerator and power 1 in the denominator. So 9 minus 1. And then let's not forget that we still have upon 9 in the denominator. And the power half as it is still intact. So 5 minus 7 is going to give me minus 2. 9 minus 1 is going to give me 8. And then we still have 9 in the denominator. And the whole thing is still raised to the power half, which means we're going to take the square root of it. Now before we take the square root of it, let's turn x power minus 2 into positive, and we can do that by simply sending it in the denominator. So now let's take the square root. Power half basically means square root. Square root of y power 8 is going to be y power 4. Square root of 9 is going to be 3. Square root of x squared is going to be x. So we have y power 4 upon 3x as our final answer. Okay, let's move on to question number 21. It says a cuboid has a square base. The length of the base of the cuboid is y centimeter. The height of the cuboid is twice the length of its base. So that means the height is going to be equal to twice of the length of its base, so simply 2y. The total surface area of the cuboid is 360 centimeter square. Okay, find the height of the cuboid. So how do you find the total surface area? Since it has a square base, that means the base and the top are going to be of the same dimensions. So y times y is going to give me the area of the base, and then I'll simply multiply it by 2 in order to take into consideration both the base and the top. And then we have twice of the height times the width, so that is going to be 2y times y, and then we will have twice of the height times the length, which is also going to be equal to 2y times y. So 2y square plus 4y square plus 4y square is equals to 360 according to the question. So 4 plus 4 is 8, 8 plus 2 is 10. So 10y square is equals to 360. Y square is equals to 360 divided by 10. So y square is going to be equal to 36, and y is equals to 6 centimeter. Now at this point, let's not get carried away and see what the question is asking for. The question is asking for the height, which we saw is going to be equal to twice the length. So the height is going to be equal to 12 centimeter. Okay, 22 number sequences. Let's fill up the pattern first. So in pattern number 3, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 dots in pattern 3. And if we continue by this pattern, we're going to have 12 and 4 and 15 and 5. Now let's talk about the number of lines. Let's change the color for that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 lines in pattern number 3, and if we continue the same pattern, which is a difference of 5, so we're going to have 17 in this one, and then we're going to have 22 in this one in pattern 5. Find an expression in terms of n for the number of lines in pattern n. Okay, so we have 2, 7 and 12. We can see that the common difference is of 5 and the first term is of 2. So we can do this by a plus n minus 1 times d. So this is going to be 2 plus n minus 1 times 5. So 2 plus 5n minus 5, and this is going to become 5n minus 3. It's always better to check your answer by taking just a random value of n and plugging it in. So if I plug in 4, my answer should turn out to be 17. Let's see, 5 times 4 minus 3. So 20 minus 3 equals to 17. That means I've done this correctly. Let's do part C, which says Anwar makes one of these paintings using 92 lines. So 92 is the number of lines. So that means 5n minus 3 is going to be equal to 92. So 5n is going to be equal to 95. Let's solve for the value of n. So 95 minus 5. 5 ones are 5, 5 ones are 5, 4 carried, and 5 9s are 95. So n is equals to 19. Now again, let's not get carried away at this point. N is the pattern number. If you look at the number of dots, we can see that the number of dots are always 3 times the number of is 3 times the pattern number. So we gotta figure out what 19 times 3 is equals to, and that is going to be equal to 57. So that means we will have a total of 57 dots, since that's what the question was asking for. Alright, now question number 23, which says the diagram shows two circles both with center O. The radius of the small circle is 3 centimeters, so let's write that. The radius of the large circle is 6 centimeters, so let's write that. Total, the minor sector AOB has an angle of 60 degrees, perfect, so that means this angle is of 60 degrees. The total area of the shaded regions is k pi centimeter square. Okay, find the value of k. Alright, so we start by calculating the area, what I'll do is I'll number the shaded region. So we'll start by figuring out what the area of region 1 is going to be equal to. So region 1. So region 1 is simply a sector. And how do you calculate the area of a sector? Theta upon 360 multiplied by pi 3 squared. So 60 and 360 when simplified is going to be 1 upon 6 multiplied by 3 squared, which is 9 pi. So 9 upon 6 pi is going to be my answer. Let's simplify this. So this is going to be 3 upon 2 pi. So since we have to keep our answer in terms of pi, I'm not going to evaluate this, and since this is paper 1, we can't do that anyway. Now let's figure out the area of the remaining region, and I'm going to shade that for you to show what I'm talking about. So this right here, the one that I'm coloring in yellow, is region 2. Now how are we going to find out the area of this region? Well, that's slightly more complicated. I'll call this region 2. So what we're going to do is we're going to figure out the area of the major sector, and we're going to use the radius of 6. So that's going to give us the entire region, this entire region. So 60 is, in fact, it's going to be 300, the outer angle, 300 upon 360 multiplied by pi, but this time bear in mind the radius is going to be 6. So let's simplify this first. So this is going to give me 5 upon 6, 30 upon 36 when simplified is going to be 5 upon 6 multiplied by the square of 6 is 36, so 36 pi. 6 ones are 6, 6 6 are 36, 5 times 6 is 30 pi. Now from this I need to subtract this region. Let me show you what I'm talking about. I am talking about this region. So subtracting this is basically a sector of angle again 300. So 300 upon 360 multiplied by pi, but the only difference is that the radius is 3, so 3 squared. So let's see what this is going to be equal to. So again this is going to be 5 upon 6, but this time it will be multiplied by 9 pi. So let's simplify 6 and 9 before we multiply. 3 2s are, 3 3s are. So this is going to be 15 upon 2 pi or 7.5 pi. So again, now what we have to do is 3 upon 2 pi plus 30 pi minus 15 upon 2 pi. This is what we have to do now. So let's simplify this. 15 upon, let's take the LCM in fact. So the LCM is going to be 2, and then we have 60 minus 15, and both of them have pi with them, and then 3 upon 2 pi as it is. So 60 minus 15 is going to be 45, so we have 3 upon 2 pi plus 45 upon 2 pi. 3 plus 45 is going to be 48 upon 2 as it is. 48 divided by 2 is going to be 24 pi, but the question said that your answer is going to be it's like k pi. So the coefficient of pi, which is 24, is the value of k. So k is equals to 24, and there we have it. 4 marks done. So this was quite a lengthy question. It wasn't as difficult given that you knew how to calculate the area of a sector and how to apply it, of course, but this was definitely a lengthy question. Alright, now we have question number 24, which says A, B and C are points on the circle, center O, AB is equals to BC. Alright, so let's write that down. AB is equals to BC. Okay, let's make a straighter line. Yeah. Prove that OAP is congruent to OCQ. Alright, so if P is the midpoint, I think I forgot to read this line. P is the midpoint of the chord AB and Q is the midpoint of the chord BC. So that means AP is going to be the same as PB and CQ is going to be the same as QB. Okay, so I have to prove that these two triangles OAP, so let's highlight them in green, is congruent to OCQ. Okay. So now we start by stating that they both have a length which is equal to the radius of the circle. So OA is going to be equal to OC. OA is going to be equal to OC. Why? Because they're both radii of the circle. Radii of the circle. Now another thing to note here is that OP is going to be equal to OQ, and the reason for that is that the two chords that we have, AB and BC, they're equal in length. So when we have two equal chords, they're going to be equidistant from the center. So we're going to write just that OP is going to be equal to OQ. Why? Because we have equal chords that are equidistant from the center. And then finally we have to write that CQ is equals to AP, and the reason for that is it's given in the question. CQ is equals to AP. We're told that AB is equals to BC, and P and Q are midpoints respectively, so of course AP is also going to be equal to CQ. So we'll just write given. So COA is 140 degrees, so that means this angle is got to be 140 degrees. And why did I take this angle to be equal to 140 and why not the other one? That's because this angle is a reflex angle, so this cannot be 140, this has to be greater than 140, and we can figure this out by taking 360 and from it subtracting 140, so this is going to be equal to 220. So we have what the angle at the center is, and that is 140. We can figure out using circle properties what the angle at the circumference is going to be, and that is going to be equal to 70. And why is that? Because angle at the center is twice the angle at the circumference. Now since we just proved that these two triangles OAP and OCQ are congruent, so that means if this angle is A, this angle will also be equal to A. So now what I'm doing is I'm looking at a quadrilateral with 4 sides obviously, and consequently 4 angles, and the sum of those 4 angles is going to be equal to 360 degrees. So here's what I'm going to do. A plus 220 plus 70 is equals to 360 degrees. So 2A is equals to 360 minus 220 plus 70 is going to be 290. So 2A is equals to 70 degrees and A is equals to 35 degrees. Now another way to do this question would be to take this angle A and this angle A, and the sum of these two angles is going to be equal to the angle that's at the circumference, which is 70. So A plus A is equals to 70. So 2A is equals to 70 and A is equals to 35. Now some of you may be thinking that well we didn't have to do that. We could have just taken A and taken the half. We could have just taken 70 and divided it by 2. Well, that's also absolutely correct, since this portion is equal to A and this portion is also equal to A. So all these methods are absolutely correct. So in any case, we have the value of angle OCQ, and that is equal to 35 degrees. So now we do the question number 25, which is the last question of this paper. So we have to evaluate P times Q. That means we have to multiply these two matrices together. So 4, 0, minus 2, 3, 1, 2, 0, minus 1. So row times column. So 4 times 1 is 4, 0 times 0 is 0. And then we move over to the next column. 4 times 2 is going to be 8 plus 0. Then we move down to the next row. So minus 2 times 1 is going to be minus 2 plus 0. And then the next column, minus 2 times 2 is going to be minus 4 plus minus 3. So let's simplify this. 4 plus 0 is 4, 8 plus 0 is 8, minus 2 plus 0 is minus 2, minus 4 plus minus 3 is going to be minus 7. Now let's do part B, where we are given the determinant, and using the determinant we have to figure out the value of K. So the way to figure out the determinant is taking AD and from it subtracting BC. So 3K minus minus 2 is equals to minus 4. So 3K plus 2 is equals to minus 4. 3K is equals to minus 4 minus 2. So 3K is equals to minus 6, and K is equals to minus 2. Okay, now that we have the value of K, we need to figure out what the inverse is. So let's plug in the value of K, 3, 1, 2 and minus 2. So we already have what the determinant is. We're given that it's equal to minus 4. So 1 upon minus 4. We're going to swap A and D. So this is going to become minus 2, 3, and we're going to change the signs of B and C. So 1 and minus 2. So we can leave this as it is, or if you want, you can multiply every element by 1 upon 4. So this is going to become plus 2 upon 4. We can simplify this in the next step. Minus 1 upon 4 plus 2 upon 4 and then minus 3 upon 4. If we simplify this, so this is going to become 1 upon 2 minus 1 upon 4, 1 upon 2 minus 3 upon 4. And this right here is your final answer, which you should not forget to write it in the space that is provided to you. So with this, we're done with this particular paper. I'll see you guys in the next video where we will be solving paper 2 of the same session. So see you then.